Need analog inputs on your Raspberry Pi? We got you covered with the MCP3008 ADC. All the parts, all the code. Come on in. Welcome to Maker's Digest. In this episode, we're going to have a look at the MCP3008 Analog to Digital Converter. The Raspberry Pi doesn't have any analog inputs. We can use this chip to easily add 8 analog inputs. Or maybe you just need some more inputs on your Arduino. This will work there as well. The MCP3008 is an 8-channel 10-bit analog to digital converter. It's similar to the quality and precision you would find on the Arduino UNO. Using this chip, you can read a variety of simple analog inputs like potentiometers, temperature sensors, light sensors, etc. One of my favorite uses is reading the inputs from a joystick, which is just a couple of potentiometers. These chips are pretty cheap too. I picked these up for about $3 each off of Amazon, which is paying a premium for Prime. You can pick them up off a place like DigiKey or something for about $2.25 USD. As usual, we're going to get right down to the implementation. Today we're going to start off with the Raspberry Pi because it's got the highest need for analog inputs. Let's jump over to the workbench and get started. All right, here we go. We're going to connect the MCP3008 to the Raspberry Pi. There's 2 ways to connect the MCP to the Raspberry Pi, and the hardware connection is almost exactly the same, but it's hardware SPI versus software SPI. Hardware SPI uses very specific pins on the Raspberry Pi as it has serial interfaces on the Raspberry Pi. There's 2 of them. If you want to hook it up with software SPI, you just, for the 4 wires we're going to use for SPI, you just pick any 4 GPIO pins and specify it in the software. We're only going to do the hardware connection here, but in the software that's on GitHub, it's got hardware and software both in there, so you can take your pick if you run my example. In order to run hardware SPI on the Raspberry Pi, we need to configure SPI through raspi config. And we'll just go through that real quick. It's really simple, but I wanted to show you how to do it. So on the Raspberry Pi, run sudo raspi config. And we want to go down to interfacing options. Enable, disable automatic loading of SPI kernel module. Would you like this enabled? Yes, I would. Interface is enabled. Mine was already enabled, so it might ask you, do you want to auto load the kernel module? Say yes. Finish, and then you'll have to do a reboot so the kernel module gets loaded correctly, but once it comes back up, you should be ready to roll. In order to connect this, we're going to need a few parts. We're going to need the MCP chip itself, an analog device to test with. This is a small potentiometer. We're going to need a whole bunch of male to male jumper wires. There are 7 of these, and another mess of male to female jumper wires, and there are 6 of these. Let's take the chip, we'll jam it in here somewhere. The pinout, I'll throw up the pinout over here so we can see what all the pins are. If you look at that, you can see that there's 2 power and 2 ground, and then the rest of them are the serial connection. So instead of trying to pull directly off of the Raspberry Pi for 2 power and 2 ground at 3.3 volt and ground, we're just going to jumper off of the Pi onto the power rail of the breadboard and then jumper from there into the chip. Let's start off with our ground. Ground is pin 6 on the Raspberry Pi. This is pin 1, so we're just going to count 1, 2, 3, 4, 5, 6. That's going to go into our ground rail. Power for this is 3.3 volts, and that's on pin 1 on the Raspberry Pi, which is here. And that's going to go into the power side of the rail. Now we can jumper in power and ground and just get that out of the way. So that for that, we're going to use our male-to-male jumper wires. Go from power into pin 16 on the MCP chip, which is top left corner here. Got another power on pin 15. This is the voltage reference. And now our two grounds. We've got pin 14 on the MCP, so we'll take off of our ground rail into pin 14. Take ground rail to pin 9 all the way down here. Now that we've got all of our power connections out of the way, we can connect our SPI connection, which are the 4 remaining wires we have that are male to female. The first one is clock. This is the serial clock interface for SPI. On the Raspberry Pi, that is pin 23. And this is one of the things about the Raspberry Pi that drives me crazy, is you kind of have to count them off whenever you need to find it. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I hooked this thing up earlier and I was off by 1 pin. I couldn't figure out why it wasn't working. And then, eventually I went back and counted it off and I was off by 1 pin, so it threw off the whole thing. Because you'll see what I'm going to do next is the next connection is digital out from the MCP chip, which is pin 12, and that goes to pin 21 on the Raspberry Pi, which is MISO. And in serial SPI interface, it is MISO is master input, slave output. And that's on pin 21. So if this is 23, we go 20, 21. And that's kind of what bit me, is because I counted off that first one wrong, and then I went backwards, and so all the rest subsequently were wrong. Next is a digital in on the MCP chip, which is pin 11, and that goes to pin 19 on the Raspberry Pi, which is MOSI. MOSI is master output, slave input, and that's pin 19. So if we were just on 21, 20, 19. And the last one is slave select. On the MCP, that is pin 10. And on the Raspberry Pi, that is pin 22. So if this last one was 23, then 22 is right here. And now that we've got all of the power and the serial connection done, we can hook up one of our devices. And our analog device that we're going to test with is this potentiometer. It's got 3 pins on it. So just pick a spot on your breadboard, plug that in. The way that this works is you hook one side of that up to ground. The other side of it to the voltage reference, and then the center wiper pin, connect that to, on our example, we're using pin 8 on the MCP chip, but that's going to be referenced as pin 7 because it starts at 0, 1, 2, 3, 4, 5, 6, 7. And now that we have this hooked up, we have all 8 of these pins on this side of the chip that we can reference in our software. So let's take a look at the software. As usual, wrote the software on my time, not yours, so it's already done. In this example, we use the Adafruit GPIO SPI library and the Adafruit MCP3008 library. They make great stuff. If you want to learn more about that, go check out the GitHub repos for those modules. Here we import sys module. From time we import sleep. And here is the Adafruit GPIO SPI as SPI, which is required by Adafruit MCP3008. As I said before, we can do software or hardware, and I did some detection in here, or just made it easy for you to change it from hardware to software if you want to. So SPI type, we have hardware. Delay is half a second, 0.5. And if you were using software SPI, this is where you would do the configuration for it. You just set the clock, master input, slave output, master output, slave input, and slave select to any of these GPIO pins. For hardware configuration, we're going to set port 0 because on the Raspberry Pi there are 2 SPI ports, 0 and 1. We're using 0, and so that's where you configure that. This next block is just a little bit of logic to detect if it's hardware or software, because the MCP module gets instantiated a little bit differently. For hardware, you have to specify what hardware port. For software, you specify which GPIO pins correlate to the SPI serial interface. This block just determines that we have fired up the software correctly, because you have to give it an analog port. If not, it'll kick it back and tell you how to use it correctly. Let's see. It just gives us a little bit of information, and down here, while true, val equals mcp.read_ADC, and then the analog port that we have specified when we ran it prints out the value, sleeps for half a second, goes back through the loop. So what we're going to see is just the value kicking out every time, every half second. Let's run this, see how it goes. Sudo python mcp, and there we go. I didn't give it a port, and it told us we needed to give it a port. So remember I said there's 8 ports here. We're on pin 8, starts at 0, so this is 7. And there we go, we're getting some values. The potentiometer is turned all the way one way, so that should be 0. Let's grab a little screwdriver. And what happens? There we go. And this will go all the way up to 1023. From 0 to 1023. So now you can take those values and interpolate them in any way you need to control whatever. This could control a rotation of a servo or a stepper motor, or whatever you wanted to connect to this thing. See if we can set it at a precise number. Let's try for 300. Oh, close enough. So there we have it. We have Raspberry Pi with 8 analog inputs on it. Right on. All right, here we go with the Arduino. The Arduino can also do software as well as hardware SPI. We're going to cover hardware SPI in this example. For this example, we're going to need the MCP chip, a whole mess of male-to-male jumper wires, and an analog device to test with. This is our potentiometer. Yeah, there we go. That's the way we want it. So let's take the MCP chip, jam it in wherever we want. And as you can see on the pinout that there are multiple power and ground on this. So instead of pulling them all off of the Arduino directly, we're going to go to our power and ground rail here. Let's start with ground. We'll take ground off the Arduino into the ground rail. Take 5 volts off of the Arduino into our 5-volt rail. On the MCP, we have pin 16 right here, needs 5 volts. So we'll take 5 volts from here off of our rail. We also need 5 volts for VREF on the MCP3008. Now we'll get our ground. So pin 16, 15, 14 goes to ground, as well as pin 9. So we'll take ground to pin 9. That's all out of the way. We can start connecting the SPI interface. The really cool thing about this is on the Arduino UNO, the pin numbers match up perfectly. So we can take pin 13, which is the S clock, that goes to pin 13 on the Arduino. Pin 12, which is master input slave output, goes to pin 12. Pin 11 on the MCP, which is master output slave input, goes to pin 11 on the Arduino. And pin 10 on the MCP, which is our slave select, goes to pin 10 on the Arduino. So that's great. Easy to remember. It's awesome. Let's set up the analog device. We've got a small potentiometer here. We'll run one side of the potentiometer to ground. The other side to 5 volts, which is our reference here. And then the center pin, the wiper, to pin 7 or pin 8 on the MCP, which is referenced as pin 7 in the software. There it is. We've got the connection. Let's jump over to the software and take a look. As usual, wrote this on my time, not yours. And again, we're going to use the Adafruit library because Adafruit's rad. If you don't have this library installed, we can easily install it with, go over to Sketch, Include Library, Manage Libraries. And just search for MCP3008 And it's the first one here, Adafruit MCP3008 by Adafruit version 1. I've already got it installed. If you don't have it installed, you'll have a button that looks like that. Click it, it'll install, and be ready to go. So here we include that library. We've got a couple of variables set up. We've got a delay of half a second, 500 milliseconds. The channel we're going to read in this example is channel 7. Here we instantiate the Adafruit MCP3008 object as MCP. Set up our serial port so we can view our readings. And here's just a little information about how the pins are set up, and it's just the UNO that works out this way. If you have a different AVR board, you'll have to Google and figure out which pins are the SPI pins for your board. The Adafruit library example has a bunch of great info on that, so you can run their example and take a look. And this library is set up default for the UNO, so you can say, you have to specify what the slave select pin is here, and that's 10. But if you leave it blank, it will just automatically select 10 for you. In the loop portion, we have a value that's an integer, and it's mcp.readADC channel, and that is channel 7. We print out the channel value here, throw in our delay of half a second, and loop back through. So every half second, it will tell us what the value of this is. Let's send that over to the Arduino and see what happens. Look at our serial monitor here. And there we have channel value of 0. And it's either 0 because it's not working or because it's turned all the way to one side. Let's check. There it is, it's working. So it goes from 0 all the way up to 1023. So you have 1024 steps reading here, and you can interpolate that any way you want for whatever purpose you have. Let's see if we can nail a 500. There it is. Awesome. There's the Arduino. We've done it. Rad, good to go. There you have it. MCP3008 analog to digital converter running on the Raspberry Pi and the Arduino. Don't forget, all of the code we used in this episode is on GitHub and linked below in the description. There's also a link to where you can buy this chip if you want to try it for yourself. Now that you have everything you need, go be creative and share with me what you make. I can be found on Facebook, Instagram, Twitter, Patreon, and all those. If you like this video, please consider subscribing and ringing that little bell so you'll be notified when a new video is available. Thanks for watching, and until next time, keep making. I didn't lose that little shit now, did I? No, there it is. Check 1, 2, check 1, 2.